Trigonometry is derived from Greek words trigonon, which means three angles, and metron, which is measure, or it is the measurement of three angles. Also, trigonometry is the branch of mathematics which deals with triangles, particularly triangles in a plane where one angle of the triangle is 90 degrees. Trigonometry specifically deals with the relationships between the sides and the angles of triangles, that is, on the trigonometric functions and with calculations based on these functions. Historical background. The history of trigonometry dates back to the early age of Egypt and Babylon. Angles were then measured in degree. It was then advanced by the Greek astronomer Hipparchus in the 2nd century of BC, who compiled a trigonometric table that measured the length of chord subtending at various angles in a circle of a fixed radius r. And based on architecture, in architecture, trigonometry plays a massive role in the compilation of building plans. For example, architects would have to calculate exact angles of intersection for components of their structure to ensure stability and safety. Some instances of trigonometric use in architecture include arcs, domes, support beams, and suspension bridges. Architecture remains one of the most important sectors of our society as they plan the design of buildings and ensure that they are able to withstand pressures from inside. And we have now the types of triangles based on sides. According to the lengths of their sides, triangles can be classified into three types, which are scalene, isosceles, and equilateral. Scalene triangle. A scalene triangle has all side lengths of different measures. No side will be equal in length to any of the other sides in such a triangle. In a scalene triangle, all the interior angles are also different. The figure given below illustrates a scalene triangle. You can see how none of the sides is equal in length. In the above given figure, you can see that all the sides of the triangle seems to be unequal. Next, we have isosceles triangle. In an isosceles triangle, the lengths of two of the three sides are equal, so the angles opposite the equal sides are equal to each other. In other words, an isosceles triangle has two equal sides and two equal angles. The figure given below illustrates an isosceles triangle. And the above figure, we can see the two sides of the triangle appears to be equal, whereas the base of the triangle here is smaller than the other two sides. So this is isosceles triangle. And equilateral triangle. In an equilateral triangle, all the lengths of the sides are equal. In such a case, each of the interior angles will have a measure of 60 degrees, since the angles of an equilateral triangle are same. It is also known as an equiangular triangle. The figure given below illustrates an equilateral triangle. The above angle, all the three sides of the triangles are equal, as well as all the interior angles equal to 60 degrees. And this is equilateral triangle. Types of triangles based on angles. Triangles can be classified into three types with respect to their interior angles, which are: first, acute angled; second, obtuse angled; and 3, right angled. For the acute triangle, an acute triangle is a triangle whose all the three interior angles are acute. In other words, if all interior angles are less than 90 degrees, then it is an acute angled triangle. The figure given below illustrates an acute triangle. So less than 90 degrees, this is also less than 90 degrees. In the above figure, we can see all the interior angles of the triangle is less than 90 degrees. Hence, it is an acute triangle. Obtuse triangle. Obtuse triangles are those in which one of the three interior angles has a measure greater than 90 degrees. In other words, if one of the angles in a triangle is an obtuse angle, then the triangle is called an obtuse angle triangle. The figure given below illustrates an obtuse triangle. And the above triangle, we can see that one of the angles is more than 90 degrees. Hence, it is an obtuse triangle. Next, we have a right triangle. A right triangle is a triangle in which one of the angles is 90 degrees. In a right angled triangle, the side opposite to the right angle or 90-degree angle will be the longest side, and it is called the hypotenuse. You may come across triangle types with combined names like right isosceles triangle and such, but this only implies that the triangle has two equal sides with one of the interior angles being 90 degrees. The figure given below illustrates a right triangle, and this is 90 degrees. In the above triangle, one among the three angles is 90 degrees, thus it is a right triangle. And a right angled triangle. The triangle of most interest is the right angled triangle. The right angle is shown by the little box in the corner. So this is the right angle or 90 degrees. And another angle is often labeled as theta. And the three sides are then called, first we have the adjacent, which is adjacent next to the angle theta, opposite or opposite the angle theta, and the longest side is the hypotenuse, and this is the hypotenuse, which is the longest side of the three sides. And for the trigonometric ratios, for sine we have opposite side over hypotenuse, while cosine or cos is adjacent side over hypotenuse, while tangent or tan, it is opposite side over adjacent side. And we have the shortcut for it is called SOHCAHTOA. For SO, S-O-H, that means sine opposite over hypotenuse, while CA, C-A-H, it means cosine is equal to adjacent side over hypotenuse, and TOA, which is tangent. Tangent is equal to opposite side over adjacent or TOA. The reciprocal of sine is cosecant or cosec, which is hypotenuse over opposite side. While the reciprocal of cosine or cos, it is secant or sec, which is hypotenuse over adjacent side. And the reciprocal of tangent or tan, it is cotangent or cot, and it is equal to adjacent side over opposite side. So these are the trigonometric ratios. And for the values of trigonometric function of angle A, so this is the angle A. We have a triangle with distance length or side A, B, and the hypotenuse from A to B, which is small c. And this is the angle theta at angle A. Hence, sine theta, which is the opposite over hypotenuse, it is opposite, which is A, over hypotenuse, which is C. While cosine is adjacent side over hypotenuse, and the adjacent side is B, and the hypotenuse is C. So cosine theta is equals to B, the adjacent, over the hypotenuse C. Next, we have tangent theta, and tangent theta is the opposite side over adjacent side. Opposite side is A, and divided by B, which is the adjacent side. So A over B is equal to tangent theta. And the reciprocal of sine theta, it is cosecant theta, which is equal to C over A. While the reciprocal of cosecant theta or cosine theta, it is secant theta, which is C over B. While reciprocal of tangent theta, it is cotangent theta, and it is equal to B over A, or adjacent over opposite side.